All right. Good evening, everyone. You are highly welcome to today's Safeoclock Health and Safety Interactive Workshop. So we kick off with our discussion for today. Today we are talking about workplace excavation safety. So as our culture has been, I'll start with a brief presentation, after which we'll give room for others to contribute and share their experience as well. So let's begin. So in this brief presentation, I will cover a definition of excavation and that of trench. I'll also look at some of the hazards associated with excavations. I'll look at the role of competent person in excavation work. I'll also discuss some employee responsibilities, and we'll conclude by looking at the protective systems to prevent excavation accidents. Let's look at the definition of excavation and that of a trench. Okay, so one thing we need to bear in mind is trench is simply a type of excavation. So excavation can be defined. You can also give it some of your other definition, but excavation can be defined as any man-made cut or cavity or depression that is formed by removing earth's surface. So that is excavation. Different parts of the world and different standards give different depth to excavation. But generally, we'll say that excavation involves removal of the earth surface, making a cut on the ground. That is what we refer to as excavation. Now, trench on its own is a type of excavation which is narrow. It is narrow. The width could be something not more than 15 feet. So that is what we refer to as a trench. So trench is a type of excavation. Excavation is a generalized removal or man-made cut on the earth surface, giving it a depth. That is what we refer to as excavation. Now let's look at some of the hazards associated with this excavation. One of them is cave-ins. Cave-ins happens when the walls of this excavation tends to collapse when it falls inwards. Okay, so that is cave-in. Cave-in has a lot of risk associated with it. It can even lead to fatality, can lead to other injuries like broken bones, dislocations, anything you can think of. If any worker or if people are inside that excavated area or inside the excavation and cave-in happens, a lot of things can go wrong. Life can be lost. So it's a very serious hazard that we also need to look into and be mindful of. Another hazard associated with excavation is exposure to hazardous substances or hazardous atmosphere. There are lots of hazardous substances, or there are a lot of hazardous gases that could be trapped inside the excavation. So including carbon monoxide, including deficiency of oxygen, other hazardous gases, H2O, a lot of them. So going inside excavation, the worker or the person going inside the excavation have high risk of being exposed to any of these hazardous substances. So another hazard associated with this is excavation could be fall. If the openings or the surroundings of this excavation is not protected, people walking by or people moving by could fall inside the excavation. It could also be flooded. The excavation could get flooded if there is a heavy rain. flooding of the excavation. People can fall inside the flooded excavation. There could be drowning. So these are also another hazard associated with excavation in the workplace. Mobile equipment. Mobile equipment being operated too close to the excavation can fall inside. And if the mobile equipment falls inside and people are also inside the excavation, then they could get crushed and injury and incident will occur. Contact with underground utilities in different parts of the world, they tend to pass underground utilities, they tend to pass their connection to utilities through the underground. Electricity, pipe-borne waters could be going through the underground. So during the excavation, these utilities could be tampered with, can get in contact with electricity, causing electrocution, fire, and all rest of it. So contact with underground utilities is another hazard that is associated with excavation work. Also, let's look at some of the statistics of injury as recorded by Bureau of Statistics of USA. It said that about 54 workers are killed in excavation-related site incident. Okay, and out of this number, 76% of them involved cave-ins. And people always get injured with this exposure to work in excavations. So there is high record of incident involving excavations or work in excavations. So this is why we are looking at these statistics, so that through the statistics, we can also know that it's a serious incident and it's a serious activity that requires adequate safety measures and safety presence. So let's look at some of the employer responsibilities. According to OSHA Standard 29 Code of Part 9, Part 1926 of this 29 code, it says that the employer should ensure that a competent person is available or is provided during excavation work to ensure that he identifies the hazards associated with the activity and eliminate them at that moment. So this is one of the requirements in excavation, during excavation activity. So what is the role of competent person during this excavation activity? The competent person should be able to recognize the hazard associated with that working condition. The competent person also should be able to classify soil types. The soil types will determine the type of protection you are going to provide. So the competent person should be able to classify soil types. It should also be able to inspect the protective systems or protective equipment provided in the excavation. The competent person also should be able to design structural ramps for protection, for excavation protection. The competent person also is responsible for monitoring the water removal equipment. He also should conduct site inspections. So competent persons are designated by employer to ensure that they eliminate any unsafe condition or unsafe act associated with excavation works. That is the general duty of a competent person appointed during excavation work. So general requirements during excavation. One of them is talking about 2 feet. What does this 2 feet mean? It means that the soils or the piles of soils removed from this excavation or during the excavation must be kept at a minimum of 2 feet away from the excavation edge. What does this mean? It means that we should prevent excavated materials falling inside the excavation by keeping the soil removed from this excavation away for at least at a minimum of 2 feet away from that edge. So the edge of the excavation must be protected to avoid equipment falling into it. The excavation must also be inspected daily before any activity is done inside the excavation. Daily inspection of excavation. There must be use of protective equipment or protective systems. We are going to be looking at some of the types of protective systems. Then the employee or the workers working in these excavations must be trained. They must attend trainings, excavation safety related trainings, and they should be aware of the hazards associated with that excavation. If there is a hazardous environment, they should be aware. If there is a hazardous substance in use, they should be communicated to, and all the information training must be passed to the employees who are working in excavation. Then the underground utilities must be identified before the start of the excavation and should be adequately and continuously monitored during while the excavation is also going on. So 4-feet rule. 4-feet rule talks about the access provided into the excavation. So while the excavation is going on, there must be access provided. And this access provided for people working inside the excavation, the rule says that it must be within 25 feet of where the employee is working. So if the excavation is very long, that means at each 25 feet, an access like ladder, step ladders, or a staircase, or any type of access that is suitable for that excavation must be provided at a minimum of 25 feet from the working location of each of those workers. Then the 4-feet rule says that the ladder provided should be properly sloped to ensure that it can be used by the people working inside there at an angle of like 4 feet. So another rule is 5-feet rule. The 5-feet rule is talking about protective equipment must be provided for any excavation that is going deeper than 5 feet. So as the excavation is going deeper than 5 feet, then protective system must be provided. We'll be looking at some of the protective systems in a few minutes time. So 20-feet rule is talking about that if the excavation goes deeper than 20 feet, then the protective system must be designed and installed by a registered professional engineer. So as immediately the excavation is going beyond 20 feet, a registered professional engineer must be responsible for designing and installing the protective systems for that excavation. That is what the 20-feet rule is talking about. Okay, now soil testing is part of the responsibilities of the competent person, the appointed excavation competent person. So part of his job is to conduct soil testing to determine the type of soil that the excavation is to be carried out on. And the type of soil will now determine the type of protective system that will be implemented to protect that excavation. So let's look at some of the types of soil. The first one is the solid or stable rock. So this is a type of soil that is stable. It's usually granite or sandstone. And this type of soil will remain stable. It will remain intact. It's not going to collapse. It will be intact while exposed. So that is the first type. Another type is known as type A soil. Type A soil is usually cohesive soil with strength with compression strength of 1.5 tons per square foot. Okay, so this type of soil is referred to as type A soil because it has a compressive strength of up to 1.5 tons. Okay, then type B soil is a type of soil that has a compressive strength that is greater than 0.5 tons per square foot, but less than 1.5 tons per square foot. Okay, so that is referred to as type B soil. Then the last type of soil is type C soil, which has a compressive strength of 0.5 tons per square foot or less. So this type of soil is referred to as type C soil. So the type of protective equipment or protective system that will be implemented will be dependent on this soil test. That is why the the competent person must conduct soil tests before the excavation is started or before the excavation gets up to 5 feet, which is where it will now require a protective system. Now let's look at the implementation of the protective system. So to protect the excavation, we can implement shoring or shading or sloping. So these are three major types of protective system that can be implemented to protect workers from incident involving an incident in excavation. Let's look at them one after the other. So shoring involves use of vertical rail and vertical systems to protect the edge of the excavation from caving in. So this shoring prevents movement of the excavated walls. It protects movement of the soil and also protects the underground utilities. So preventing any of the movement of these items in that excavation, thereby protecting the workers from these items falling on them. So that is what shoring does. Shoring consists of posts, wells, there's sheeting also in shoring system. Okay, so this shoring, like the picture on the screen, the shoring tends to ensure that the walls of that excavation are intact. They are not moved and they are not shaking. That is what shoring does, and it protects the people working inside the excavation. So another type of protection system or protective system is benching or sloping. Like the name means, it means taking an angle, excavating doing the excavation in consideration of an angle. And this has to do with the type of soil. We looked at the types of soil. So the type of soil will determine the angle of that your slope during the excavation. So if that soil is type A, then your slope can be in 53 degrees. Okay, but if it's a stable rock, then you can maintain a 90 degrees excavation. If it's a type B type of soil, then the slope must be up to 45 degrees. And if it's a type C soil, then the excavation will maintain 34 degrees slope. So this will ensure that the excavation or excavated walls does not collapse. There is no caving, and the soil itself does not move because it was excavated in slopes and there is proper benching. Okay, so that is for sloping. Let's look at shielding. Shielding is in a way of constructing a boss that will protect the workers who are working inside that excavation. So shielding is more concerned about protecting the workers working inside the excavation as well as protecting the excavation walls. So if there are materials falling from the edge or from the walls of the excavation, with the use of shading, then the workers working in that excavation will be protected. Those materials will not fall on them. It protects them from obviously minor incident or minor cave-ins, right? So because if it's a heavy cave-in, they can, even the shading boss can also be damaged and the people can be trapped inside the excavation. So shielding protects the workers from materials falling from the walls or from the edges of the excavation inside the excavation. So this is a typical example of a shading boss. Installing and removing protective equipment must be done by a competent person. Not everybody should be allowed to install protective equipment. The competent person who is authorized and who has the skills and the qualifications, the experience in installing protective equipment should do it. It should be properly supported and it should not be overloaded, like the shielding boss should not be overloaded. The removal should be from bottom up, should not start removing from up, should remove from bottom to up. And the backfilling should be going on immediately as the removal is going on gradually. While the removal is going on, the backfilling is, so you backfill and you remove a particular layer, you backfill again. That is the process of removing these protective systems. Okay, some of the other safety considerations while working in excavation include the excavation should be inspected daily, and the excavation should also be inspected after a rainstorm or if there is a poor weather condition that we think that may have affected the excavation, then inspection should be conducted. The employees should not be working under suspended load. If there is equipment working from the top, then nobody should be working inside the excavation at that time. Okay, the employees should be wearing high visibility vests because of equipment movement for them to be identified from afar. So reflective vest is also recommended. Equipment used in these excavation activities should be properly inspected and they should be in good working condition. The workers should have hard hats. There should be proper ventilation inside the excavation. Okay, in summary, we looked at the definition of excavation and that of trench. We said that excavation is general term used for all removal of the earth surface, forming a hole below the earth surface. Then we say that trench is a type or a typical type of excavation which the excavation is narrow and is not usually more than 25 feet in width. Okay, and we looked at some of the OSHA requirements that says that the employer must designate a competent person to be in charge of the excavation. And we looked at also the protective systems, including shoring, benching, and shielding. So this is the summary of what I was able to discuss today. So I will then keep the floor open and allow others to contribute. Thank you for your time.
Hello and good evening, everyone.
Good evening, Mr. Jassy.
Yes, thank you so much for your presentation. You made a very brilliant presentation. You basically touched on everything. However, there are some few additions that I want to make to the presentation that you have made. For instance, in addition to the method of protections that you enumerated in your presentations, there is also benching. Benching as a method of prevention of the collapse of excavation. Benching method is done by excavating making excavation of various levels. And I will give a brief explanation of that. For instance, if you are going to work in an excavation where you need 2 meters by you begin the excavation by first excavating 8 meters length by 3.5 meters wide. Then you make that excavation for about 1 meter or 800 mm. Then from there, you come in inward of the 3.5 by 8 that you have made. You now take another level. For instance, 7 meters by 3 meters. Recalling that the first one you made was 4. Then you come again, you now make 6 meters by 2 meters. So if you look at it from the top, the excavation, the width of the excavation and the length is gradually decreasing. You started with, for instance, the width, you started with 4 meters, then the next level, 3 meters, and the third level, 2 meters. Depending on the size, this method of excavation is mostly employed in mines, large excavations, where you have trucks driving in. They collected their excavated materials are loaded into them, and they will drive out. They are mostly common in coal mine, iron ore mine, and other types of mines, large scale excavation. Then for excavation within the oil and gas industry, it is required that the spoiled, that is the excavated materials from the excavation, are kept at a minimum of 1 meter from the edge of the trench. Yes, I recognize the fact that the standard states that the materials should be kept minimum of 600 mm or 2 feet. But in the oil and gas industry, their requirements are mostly 1 meters. That is, their requirement is more stringent than what the standard says. That is another one. Then for deep excavation, deeper than 4 meters, for instance, an excavation that has to do with the installation of an underground tank, either a diesel tank or a sewer tank, which could go as deep as 4 to 5 meters deep. For this kind of excavation, the approved method of ingress is either by stairway, like you mentioned, ladder, or ramp. But in the case of stairways, the stairways that are carved into the wall of the excavation are mostly not acceptable in the oil and gas industry. So what you do is that you get competent persons, mostly scaffolders, to erect stairway made of scaffolding materials into the excavation. And it is a very good practice. Although this is not a mention in the standard, but it is a common practice in the oil and gas industry that before people go inside the deep excavation to work, an emergency rescue exercise needs to be carried out. For instance, as the people are walking inside the excavation is 4 or 5 meters deep. If somebody slumps, if one of the employees slumps inside, how do you get the person out? So this drill needs to be carried out first, so that if there is any challenge encountered during the drill, this challenge has to be addressed. And even though there was no challenge, if the drill goes smoothly, while people are inside the deep excavation working, emergency rescue team members should be on standby, ready to go into action in case there is an emergency. So this is also another part that I wish to add. Then last and not the least is the duration that an excavation should be left open and the type of barricade that should be stored. If the excavation is such that is going to be excavated and backfilled the same day, for example, the excavation had been made in the morning hours, but the backfilling will take place after lunchtime, then the excavation needs to be barricaded with soft barricade, that is with a caution tape. But if the excavation is going to be left overnight, then the barricade needs to be made with hard barricade, which is with solid scaffolding materials. And this goes on for any duration that the excavation needs to be left open, more than the shifted period. So it could be open for 1 week, could be open for 2 weeks, but the hard barricade must be in place. And yes, you are very correct. Inspection needs to be made every day and when there is an inclement weather. Then, if the excavation is up to 4 meters or deeper, then gas testing needs to be carried out to determine whether dangerous atmosphere is existing. So even if the test was carried out in the morning before the commencement of work, when the workers are back from lunch break, the testing, the atmospheric testing needs to be done again, just to make sure there is no dangerous atmosphere while the workers were away before they will continue working again. So these are the few additions I feel like adding to the brilliant presentations that you have made. Once again, thank you so much. And also let us not forget signage and notice for open excavation. There must be signage warning people of an open excavation. People should keep away. So thank you so much.
Thank you very much, Mr. Jackson. Thank you for your brilliant and most anticipated contribution. We are happy to always have you here.
Thank you.
Okay, Mr. Stephen, you came late. Amajade, go ahead.
Yes, good evening, Mr. Presenter. I really appreciate your analysis of the topic and really went well. Even the last speaker, what he said makes a great meaning to the topic of discussion. I just wanted to put in 1 or 2 things. I've really been involved in projects that involve excavation for some time, and my experience with excavation is quite a robust one. I've really done excavation in the oil and gas industry before, and in the course of our working in excavation, there might be need for us to consider other hazards pertaining to excavation. You know, in excavations, there may be need to do heavy lifting. There might be need to do hot work in the excavation space. So there's need for us to make our risk assessment quite a robust one. Like the last speaker said, there's need to also carry out a gas testing excavation because of the presence of hazardous gases or atmospheres present in these places. And also, before you even consider working on excavation or consider carrying out digging or excavation, there's need to have a layout of the area, the design of the premises which you want to excavate. Now, in doing this, you need a scanner or something that can locate the very service equipment. But excavation are not just going to just because you want to go into it. You need a subject matter expert, like you said, a competent person that has an understanding of the soil type, a civil engineer also that has an understanding of how this job ought to be done properly without injury to personnel. Like the last speaker also said, there's need also when the excavation is beyond 4 meters, as he said, for protective mechanism to put in place, shoring, benching, and the likes. Now, and in carrying out this shoring and benching, there's need to carry out a thorough bracing of the area, because you cannot just show and leave it like that. If you show and leave it, there may still be a collapse at the end of the day. So the two edges ought to be braced. Very, very important, because we have seen excavations where before you know it, after you say you have done your shoring, what happens? The next day you come, you find out that the edges of the excavation, they've collapsed. There's a cave-in because the shoring material, they bow to the pressure from the soil at both sides. So excavation is a very hazardous activity, and there's need for proper planning. The planning is very key in executing an excavation job. And if you have in the oil, like we have in the oil and gas industry, where we have an already combustible atmosphere, where you have a zone 0, you know that there's additional mechanism you have to put in place. You need intrinsically safe equipment to be used within the excavation area, even outside the excavation too. Then, like last speaker said, there's need for a rescue person, a robust emergency procedure to be in place. And then also, excavations are not things that you just there's biological hazard that you face in excavation too. So the personnel should have this awareness that after work, there's need for proper cleaning up. Because of course, we know that their body is going to be stained, messed up, that kind of thing. Then there's also need in the course of working in excavation that's made of soft soil, or also carry out what we call probing. Probing helps to really, because you cannot just take, if perhaps you identified, you identified buried services, there's need for you to probe. You cannot just carry a shovel and start digging where you have electrical installation, buried services, gas pipes, water pipes, and you need to probing this. You try and you don't apply pressure using a shovel. You try and use the shovel in such a way that you have this understanding that there are buried services. You don't use force. Removing topsoil before you get to the beneath the excavation in a more controlled and relaxed way. So those are my little contributions. I appreciate your topic this evening. It really makes a great meaning to me. Thank you.
Thank you very much, Omajede. Thank you for your wonderful contribution. I learned a lot from you as well. Thanks for your time always.
Yes, other contributor, though I came very late, other contributor and you yourself, as Mr. Johnson have dealt with the topic, I will use the word extensively, and based on the knowledge we have shared, I will say I've refreshed my memory. Okay, because sometimes these are things that probably we might have come across, we might have heard about. There's no doubt, especially those of us who have some years of experience within the health and safety field. But sometimes this is the essence why we come like this on a weekly basis. I just want to commend every one of us that have made one or two comments. I'm not going to say anything more than what has been said. What has been said so far is what is applicable everywhere, and basically what I just want to say is that, every industry still has their own will I say standard. When he was talking about the distance at which you put the spoil of the excavation and all that. So it's just like when you come to Qatar, when you work within the ASHGA project, we have the ASHGA standard requirement from the Qatar construction specification. When you go to the oil and gas, probably they might be using OSHA standard, so it varies. As a professional, we have to work based on the industry we find ourselves at a particular point in time. But the most important thing is we know what to do. We know the right thing to do. We know the right question to do, as a professional, because you can imagine as a professional, you're in a site, they want to do a construction, they just start excavating like that. So we need to bring our advisory expertise into it to make those especially those geotechnical engineers and all that, who are responsible, because it is not our own duty or our responsibility to go and start testing the soil. So there are people, there are departments who are responsible for that. But all this knowledge, we need it so that when people are speaking, we can speak, in as much as it's not totally our area of expertise, but as a safety, we need to understand so that in case they bring a quack to come and do the job, then we can speak and say, no, this is how it's supposed to be. You get it? So for me, that is where I believe these are where we are supposed to get some extra knowledge, which for me, I call them transferable skills. It is not our duty to get such skills, but we can acquire it. It will be a plus to us so that when people are speaking, when you speak, they know, this guy understand. How does he has anything to do with geotechnical knowledge and all that? So it's very good. It's very important, Mr. Johnson. Like I've said, you've given a lot of nice presentation, and the contributors have done well by giving us based on their own experience in their various industry. So I will just keep encouraging us, and also let us try to invite people also, because I could see that the number is, I would say, is not encouraging. I know for some areas, we have challenging time. It could be our work. It could be that some people are out of jobs and things like that. But then we still have to keep encouraging ourselves. We should not limit the knowledge within ourselves. Let's try to encourage people to join. We should be growing. We should be growing. Not every day we come, we'll see 4, we'll see 5, we'll see 6. For me, it's not encouraging. So let's try. I know it's not easy, even from my side, but let's try and see how we can encourage people to come up on this our webinar weekly. Thank you very much.
Thank you, Mr. Stephen. Thank you for always being available, and thank you for your expertise. Majede, your hand is up.
Sorry. I will. Yeah, based on the topic I said about the IA stuff, I will try and make sure that by this the next, I think next week, I will try to make sure that I have a comprehensive preparation slide for that. So we should all be expectant, and also we should try to invite people, just like I've said, because it's a topic that a lot of people should be interested in, and because if you go to many countries in the world today, if you are discussing a topic, they are bringing IA into it. If you are talking about environmental, if you are talking about sustainability, they are bringing IA into it. So the world has gone beyond. There is no field today that you cannot find IA coming into play. You understand? So even in the investigative area, in the government sector, even in Qatar, some months back, I can see that in their judicial system, they've introduced this artificial intelligence and all that. So these are things that we need to understand, that we need to live with. And we know that it has its own threats, it has its own challenges. So how can we boycott that? How can we move with such threats and challenges as a professional? So by next week, I'm going to be sharing some insights which I believe will be beneficial to us as an health and safety practitioner, irrespective of the challenges that is ahead. I think that's what I would like to share in respect to that for next week. Thank you.
Okay, so I will share the flyer on time, God willing, by tomorrow or Sunday. So I will make sure the flyer is out, so we circulate it and try to get more people to be in attendance. Amajede, you were raising your hand.
Yes, sir. I just want to add one or two things to what I've said before. Yes, really, in my first experience working in excavation, it was quite an experience because I was taken with surprise. Why I said that is we actually were doing an excavation in an helicopter landing area where helicopters and planes land, so offshore. And you see, these kind of places, we didn't have the awareness. And you see, there's what we call FODs. FOD stand for foreign object debris. Now, to a common man, he will just feel like after excavating, you do a simple housekeeping and go back home and go and relax. Now, as for an area, a helicopter-prone area or a place that flights land and live from, cannot live an excavated area in that way, and you are not allowed to work in the daytime. So you can see excavation, simple excavation work has become so complex. You see, so when finishing excavation in an airborne area, what you do a complete cleanup of proper housekeeping of the site after work. So no flying objects should be left in the workplace. You do a proper cleanup. So when you come back the next day, even sometimes you are told to clean as you go. You understand? So you discover that these areas, because there's an understanding that if these objects find its way into this aircraft, there's aircraft damage at the end of the day. So you understand? So, and even we're also operating close to it where we had Jet A14. So you can see that excavation is something that involves all that kind of jobs, all that kind of hazards are being introduced. You should not limit yourself to just a simple the hazards that pertain to excavation. Other things are being involved also. So in continuous excavation is a high risk work. We ought to have our safety caps really on. That's a little thing I just wanted to add to what I've said before. Thank you.
Thank you very much. Mr. Jackson, please go ahead. The discussion is getting more interesting.
Thank you so much. I feel like adding this because I know most of you guys, you work out there in the desert area. However, talking about excavation, if you are working in the desert, it may not readily come into play. But if you are working in a tropical forest area, place like Nigeria, then if the area is a waterlogged area, for you to prevent water accumulation in the excavation, either before people go in or while they've gone in, then you need to do dewatering. It's a very, very important prerequisite. You need to do dewatering, and the dewatering equipment are installed by competent subcontractors. One of the manufacturers of very good dewatering equipment within the industry is called the Rabanap. They are based in Germany. Years ago, when I was working with Chevron in Escravos, we used to make use of their equipment so much. So dewatering of the area is very, very important to prevent water accumulation. I know this is not so common in the desert area, but in tropical rainforest area, it does. Then, of course, when I made my initial contribution, I didn't start with the permitting process. But while obtaining permit to work for excavation certificate is also obtained. Excavation certificate is to indicate that the area has been checked and there is no underground services within the area to be excavated. Then, last and not the least is EROW certificate or USO certificate. This one is mostly applicable to war-torn countries. A place like Iraq, where I worked for so many years. EROW means explosive remnants of war, or USO, unexploded ordnance. In a place like UAE, it's not applicable. Nobody talks about it. Qatar, I'm sure too that there will be no much talk about it. But in a place like Iraq, it's a very, very prominent requirement before any excavation takes place. This is because during the many wars that have been fought in Iraq, first it was the Iran-Iraq War of 1980 to 1988, then the first Gulf War and the second Gulf War. So most of the landmass are littered with unexploded ordnance. So because of that, before you mobilize to any site, first you will have to get EROW clearance certificate from your client. The clearance certificate is usually issued after the engagement of EROW clearance contractor, who will come and sniff the area with unexploded ordnance detection equipment. Once they have checked the entire area and sure there is no unexploded ordnance, that certificate will be issued. If they detect that there is any, then such ordinances will have to be taken out by bomb expert. This aspect of the requirement is managed by the client. You, the contractor, all you need to do is to request the EROW certificate from the client. Then again, especially if the project is a pipeline project, then it is paramount that there should be an EROW certificate covering the entire length of the pipeline to prove that yes, the entire length of this pipeline has been checked and there is no unexploded ordnance or unexploded bomb. Actually, these bombs, they are scattered and they're everywhere. We encountered most of them while I was working there because I worked there for 10 years. So, but the good news is that at least nobody was injured. But they are there, and this is a very, very serious precaution that is taken before any excavation is carried out. Thank you.
Wow, that is so interesting. We that are working in this part of the world where we've not fought war, we are not praying for war to come to this side so that we don't have to start.
Imagine that.
We don't have to start looking for unexploded bombs before we start excavation. We just concentrate on the underground utilities and we'll do our scanning and we are good to go. So that is a very huge experience. Thank you for sharing with us. We are learning every day. That was a very great experience. Even with this thing you are saying, if I get a opportunity there, I will not go. It's a very high risk.
No, you will go. You will go. The adequate precautions are in place. So it's not a thing that can happen to anybody through carelessly. But the thing is that everyone knows that this hazard is there and precautions are being taken to make sure they are mitigated. For instance, couple of times during general housekeeping, then we were working in a place called Umukasa Gas Storage Terminal. 2 bombs were discovered, but the company also has a bomb handling expert. So once such is found, everybody will just keep clear. The area will be barricaded, and the detonation expert will be contacted, and they will come to site and come and remove them.
That's great.
Yeah.
Thank you very much for this knowledge.
You are welcome.
Stuff.
Yes, to add what Mr. Jackson have said, actually, for those of us who are even in the desert area, when we do excavation to a certain meter, we do experience water also. So in Qatar, when you are doing especially this high-rise building, in the Middle East, most of them they have this basement parking. Sometimes you see the basement will get to about 2 to 3 floor, basement. So that is the pattern they do in the Middle East, especially in Qatar and UAE. So definitely when you begin to excavate to a certain level, you encounter water. So we have a lot of dewatering company here also within the Middle East who does that job. I believe probably maybe Mr. Johnson did not mention that along when he was giving his presentation. And for the issue of bomb, yeah, I'm a living witness to that because I grew up from Ikeja Cantonment in Nigeria, Lagos, and during the bomb blast, I was there. So I could experience after a series of years, I could find out that even some people were still discovering bomb under the ground, even in their houses, after some time. So it's just been peculiar to Iran and all that. So at least because it was a war zone before, so they knew that it was what they are trying, they are more likely to encounter, as a risk factor, stuff like that. So that is why such kind of permit or approval is required in such area. I think everybody have done well by giving their experience. Thank you very much.
All right, guys. Thank you very much. I really learned a lot today. So our number is few, but the knowledge is very much. So thank you guys for showing up, and thank you for your wonderful contribution and the experience you shared with us.
Thank you so much.
Next week we'll talk about AI and safety. So we'll start sharing the flyer on time so that we'll be able to invite other of our friends. So see you next week and have a blessed day.
Thank you so much.
Thank
and
you.
bye-bye, everyone.
Bye-bye. Amajide, bye. Stephen, bye. Jackson, bye.